App ID. In this module, we'll look at an overview of application identification, or App ID, using App ID in a security policy, identifying unknown application traffic, and updating App ID. Though the firewall can classify traffic by port, as does a traditional firewall, the next generation firewall is designed to examine the application associated with the traffic to provide more granular control over data on your network. For more information about the packet handling sequence inside of a PAN-OS device, refer to the Packet Flow Sequence in PAN-OS document available on the Palo Alto Networks support website at live.paloaltonetworks.com/docs/doc1628. Application identification. The term application does not have an industry-accepted definition in the way that session or packet does. In Palo Alto Networks terms, an application is a specific program or feature whose communication can be labeled, monitored, and controlled. Applications can be delivered through a web browser, a client-server model, or a decentralized peer-to-peer design. Applications include business tools and services that must be allowed, and entertainment or personal services that might need to be blocked. App ID uses multiple identification mechanisms to determine the exact identity of applications traversing the firewall. Accurate traffic classification is the core of any firewall, with the result becoming the basis of the security policy. Security rules within a Palo Alto Networks firewall can specify applications to allow or block. Traditional firewalls classify traffic by port and protocol, which at one point was a satisfactory mechanism for securing the network perimeter. However, today's applications can easily bypass a port-based firewall by hopping ports, using SSL and SSH encrypted traffic, sneaking across port 80, or using non-standard ports. App ID is the Palo Alto Networks traffic classification mechanism that addresses the traffic classification limitations that plague traditional firewalls. In the example, the port-based security policy rule allows any traffic from the private zone to the public zone as long as it is going to ports 20 and 21, as defined in the service FTP. The actual traffic might or might not be FTP traffic. The application-based security policy rule allows only FTP traffic from the private zone to the public zone that is going to ports 20 and 21, as defined by the service setting of application default. If the traffic that is going to ports 20 and 21 is not FTP, it will not be allowed by the firewall. Traditional firewalls use port blocking to control traffic. To allow a service such as DNS that uses port 53, the traditional firewall is configured to allow port 53 traffic. The Palo Alto Networks Next Generation Firewall is configured to allow the DNS service. If you configure the firewall security policy rule to use the application default port, then the firewall allows only DNS traffic on port 53 and denies all other non-DNS traffic on this port. In this way, the Palo Alto Networks firewall protects the network from evasive applications that switch ports or use non-standard ports. This protection is not available on a network protected by a traditional port-based firewall. On a port-based firewall, DNS would be allowed on port 53, but so would other evasive applications attempting to use port 53, such as BitTorrent in the example here. In such an environment, the network would be completely unprotected. The previous example dealt with a well-behaved, known threat. The situation changes if the threat is unknown, like a zero-day virus. In the application IPS Blade Server example, the zero-day virus using port 53 is allowed through the firewall because it is using an allowed port, and it is not BitTorrent. The unknown traffic is allowed by the IPS because it has not been specifically blacklisted by the IPS. This problem is inherent with application block policies. The device cannot block what the device does not know. Not only does the zero-day malware get through, but no logs are generated to identify this occurrence. The Palo Alto Networks firewall is configured to allow only DNS application traffic. Even if the zero-day malware is unknown to PAN-OS software, it is still not allowed to pass because it has not been specifically identified as the DNS application. Also, the blocked traffic is logged, making the occurrence known for further analysis. A Palo Alto Networks firewall examining UDP packets often must examine only a single UDP packet to identify the application. In most cases, all the information that the firewall needs is contained in the first packet. This example shows a single, lightweight UDP packet. The packet contains all source and destination addressing information. It also includes the application data that will be used to identify the traffic so that it can be processed by the security policy. Note, the Lightweight User Data Protocol, or UDP Lite, is very similar to the User Datagram Protocol, UDP, but also can serve applications in error-prone network environments that prefer to have partially damaged payloads delivered rather than discarded. When this feature is not used, UDP Lite is basically identical to UDP. Applications that use TCP usually require multiple packet transfers to identify an application. This example shows an HTTP connection request. The first packet is a TCP SYN packet. Although the first packet does contain the source and destination addresses and ports, it contains no application data. In fact, the next two packets just complete the required TCP three-way handshake and do not contain any application data. The application data could reside in either the client's HTTP GET request or in the server's reply. For this reason, the firewall might have to examine the fifth packet, for example, before AppID can detect either the application or the presence of encrypted traffic. If the traffic is encrypted, the firewall must evaluate the administrator-defined decryption policy to determine what to do next. Depending on the configured policy, the traffic could be allowed or blocked in either encrypted or decrypted form. Decryption is described in another module. Palo Alto Networks AppID uses four major technologies to help identify applications. Application signatures, a database of application signatures updated weekly as part of the firewall content updates. Unknown protocol decoder, an AppID heuristics engine used to look at patterns of communication. It attempts to identify the application based on its network behavior. For example, this type of detection is required for applications that use proprietary end-to-end encryption, such as Skype and encrypted BitTorrent. Known protocol decoders, a set of application decoders that understand the syntax and commands of common application. And protocol decryption, SSL and SSH decryption capabilities. Network traffic is first classified based on its IP address and port. The firewall consults the security policy to determine if it should allow or block the traffic based on IP address and port. During this initial security policy check, the application is set to any. If the traffic is allowed, then a session is created, and AppID then looks for an application signature. The firewall uses its known protocol and unknown protocol decoders to identify the application. If App ID determines that either SSL or SSH encryption is in use and a decryption policy is configured, the traffic flow could be decrypted and the unknown and known protocol decoders could be applied to the decrypted traffic to detect an application signature. If the traffic is not decrypted, then the traffic would be identified as the SSH or SSL application. If an application signature cannot be identified, the traffic can be labeled as unknown TCP or unknown UDP. After an application has been identified, the firewall checks the security policy to determine whether to block, allow, or allow and scan for threats. Next, using App ID in a security policy. Network traffic can shift from one application to another during the lifetime of a session. In the illustration, App ID cannot identify the traffic from only a TCP SYN packet. Even after the TCP three-way handshake has completed, the firewall would report insufficient data rather than an application name. However, once an HTTP GET is detected, App ID can report the application as web browsing. As more packets are received, App ID might be able to further classify the traffic. In the illustration, the traffic is further identified as Facebook base and then Facebook chat. Some applications can depend on one or more other applications. Network traffic can shift from one dependent application to another during the lifetime of a session. For this reason, when you create a policy to allow dependent applications, you can ensure that the firewall allows the other applications on which the application depends. In this example, user Joe in one zone wants to access Office on demand in another zone. App ID scans the traffic and finds an HTTP GET, which matches the web browsing application. The first rule is matched and the HTTP connection is allowed. The Office 365 rule is not checked at this time because a matching rule has already been found. Because security policy rules are examined for every packet, the firewall can detect application shifts within an established session. When Joe tries to access Office on demand, an application shift in the current session is initiated. The App ID engine detects the shift and finds the application signature for Office on demand. The Office on demand application does not match the first rule, so the firewall moves on to the next rule. The second rule matches, so Office on demand is allowed to run. However, the Office on demand application depends on the MS Office 365 base and SharePoint Online applications, so they are included in the rule. Does the order of the two rules matter in this example? In this example, the order is not relevant. Traffic that matches one rule cannot match the other rule, so neither rule prevents the other from being evaluated. Palo Alto Networks maintains a database of known application signatures for use in the App ID engine. Each signature covers multiple versions of an application. Updates to the database are issued weekly. Application dependencies are among the items listed in the App ID database. To display application dependencies in the web UI, select Objects, Applications. Application dependency information also is available in Applepedia at http://applepedia.paloaltonetworks.com. In either the web UI or Applepedia, find and select an application and look for the Depends On field. For a firewall to be able to pass application traffic, any applications listed in its Depends On field must also be allowed by the security policy. In the example, notice that the 4 applications listed in the Depends On field must be allowed explicitly on the firewall for use of the application Office on Demand. Therefore, you must create a rule to allow these applications within your security policy configuration. If the application that another application depends on is not allowed in the security policy, you will receive warnings when you commit the configuration. For many dependent applications, the AppID database implicitly allows the required parent application without the need for you to explicitly add the parent application to the security policy. In the example, the Facebook Base application implicitly allows the required web browsing application without the need for you to explicitly add a web browsing rule to the security policy. The Facebook Chat and Facebook Mail depend on Facebook Base. So Facebook Base must be explicitly added to the rules to enable users to chat or email using Facebook. AppID defines implicit dependencies because the addition of parent applications to a rule in the security policy could allow more traffic than intended. For example, enabling web browsing just to allow Facebook Base would allow users to browse other websites. An administrator would have to configure additional security policy rules to control other website access. Security policy administration is simplified when AppID implicitly allows parent applications. Implicit permissions for a parent application are processed only if you have not added an explicit security policy rule for the parent application. This implicit support also applies to administrator-defined custom applications that are based on HTTP, SSL, MSRPC, or RTSP. You can determine implicit application dependencies using the Firewall Web UI or the Applepedia website. In the Web UI or Applepedia, find and select an application and look for the Implicitly Uses field, which lists any implicitly allowed parent applications. In this example, Facebook Base implicitly allows the parent application's SSL and web browsing. An application filter is an object that dynamically groups applications based on application attributes that you select from the AppID database. The selectable attributes are category, subcategory, technology, risk factor, and characteristic. Application filters are useful when you want to enable access to applications that match filter criteria rather than match specific application names. For example, you might want to enable employees to choose their own Office programs, such as Evernote, Google Docs, or Microsoft Office 365, for business use. To enable these types of applications, create an application filter that matches on the category Business Systems and the subcategory Office Programs, as shown in this example. New applications added by Palo Alto Networks to the AppID database are classified by category, subcategory, technology, risk, and characteristic. Any new applications automatically will match the application filter you define and will be added dynamically to the dynamic application group. The use of dynamic application groups also simplifies firewall administration because changes to a dynamic group do not require a firewall commit. An application group is a static administrator-defined set of applications. Application groups enable you to create a logical grouping of applications that can be applied to security, QoS, and PBF policy rules. An application group is used when you want to treat a set of applications similarly in a policy. Application groups ultimately simplify administration of your rule bases. Instead of adding the same list of applications to multiple rules, you can create an application group and add the group to multiple rules. You still must issue a firewall commit after updating an application group. When you plan for application groups, consider how you want to enforce access to your applications and create separate application groups for each type of access. For example, you might have some applications that you allow only your IT administrators to access, and other applications that you want to make available for any known user in your organization. In this case, you create separate application groups for each of these policy goals. As another example, although it is best practice to enable only default port access to applications, you might want to group applications that are an exception to this practice and enforce access to those applications in a separate rule. An application group is manually configured to include applications, application filters, and other applications groups. The diagram illustrates the possible ways that application groups and filters can be nested. You can configure firewall policy rules, including the security policy rules, to match specific applications, application filters, and application groups. Application filters and groups are added to the security policy rules just like single applications. They can be used to either allow or deny applications. Security policy rules on a PAN-OS firewall match source zone, destination zone, application, and service. The application and service URL category columns specify which applications can be allowed or blocked, and on which port or ports. The services service HTTP and service HTTPS are the only predefined services. Custom services can be created using objects, services. In the example, a custom mailbox access service is defined, and TCP traffic associated with this service is expected only on TCP ports 110 and 143. Application default. This option configures the security policy to allow an application on only the standard ports defined for the application in the AppID database. Service HTTP or Service HTTPS. These predefined services use TCP ports 80 and 8080 for HTTP and TCP port 443 for HTTPS. Use this security policy setting if you want to restrict web browsing and HTTP, HTTPS to only these ports. Any. This option matches any TCP UDP port. This service typically is used to deny applications. And select. This option enables an administrator to choose one or more services, even custom services created using objects, services. Palo Alto Networks recommends that you use the service application default when configuring a security policy rule. If the application block page is enabled and a security policy rule denies a web-based application, then a user receives a browser-based response page. The default response page includes the prohibited application name and the user's name if the user ID feature has been configured. If user ID has not been configured, then the user's name appears as an IP address. Application block response pages must be enabled using an interface management profile. The generic response page might result in additional support calls if users do not correctly interpret the message. You can create and upload a custom HTML response page. For more information about creating custom response pages, use the WebUI's Online Help or the PAN-OS 8.0 Administrator's Guide at https://www.paloaltonetworks.com/documentation. Identifying unknown application traffic. When you add a Palo Alto Networks firewall to your network, one of the first tasks is to identify your network traffic. Because the Palo Alto Networks firewall is not a port-based firewall, identifying traffic means identifying the applications traversing your firewall. Applications can fall into one of two main categories: applications known to AppID and applications unknown to AppID. Applications known to AppID are named in the traffic log, viewable at Monitor, Logs, Traffic. For example, an application could be identified as FTP or SMTP. An application that uses HTTP initially might be classified as web browsing, but as more packet data becomes available, the application could be more specifically identified, for example, as Google Docs Base. When AppID cannot identify an application, the traffic can be identified as unknown TCP or unknown UDP. One exception to this identification is when the traffic contains HTTP. Such traffic is identified generically as web browsing. Identifying network traffic is an iterative process. First, create security policy rules to allow or block those applications that are known to be traversing your firewall. Then, create a temporary security policy rule to detect unidentified applications traversing your firewall. For example, known good allows necessary and expected applications through the firewall. The known bad apps blocks identified applications that are not permitted on your network. However, most organizations acknowledge that they do not yet know all of the applications in use on their network. These unidentified applications must be identified so that specific security policy rules can be added to allow or block them. In the example, unclassified apps enables you to determine which other applications are encountered by the firewall. Traffic that does not match the first two rules is matched by unclassified apps. With the rule's action set to allow, the firewall receives enough packet information, even if the protocol is TCP, to be able to identify the application. The application could be specifically identified or identified as unknown TCP or unknown UDP. The newly identified application is listed in the traffic log. Use this information to create a new rule to allow or block the application. Note, if this last rule was set with the action of deny, in the event of an incoming TCP connection attempt, the firewall would classify the application as unknown, which results in a traffic log entry with an application label of not applicable. You should be actively reviewing your logs to identify and classify unidentified traffic. You can expose your network to danger if you continue to allow unidentified applications. As an alternative to creating a specific rule to capture unidentified traffic, you can enable logging on the default interzone default rule. By default, logging on this rule is disabled. At least 3 methods are available to the firewall for processing traffic identified only as unknown TCP, unknown UDP, or web browsing. The first method is to create administrator-defined custom applications. First, use a network packet capture to identify unique bit patterns in the application. Next, create a custom application signature to match that bit pattern, and then name the new custom application. Lastly, use the custom application in a security, QoS, or PBF policy rule, just like applications identified in the Palo Alto Networks AppID database. Your second choice is to configure an application override policy rule. For example, if you need to control a custom application, an application override policy rule can be used to identify traffic for that application based on its source zone and IP address. its destination zone and IP address, and its port and protocol. Creation of an application override policy prevents the firewall from using App ID to process the Layer 7 data in an attempt to identify an application. Application override also disables security profiles. You still must create a security policy rule to allow the application to traverse between firewall zones. The third method to control unknown applications is to block unknown TCP or unknown UDP traffic, which could block more traffic than you intended. The unknown TCP or unknown UDP traffic seen inside an organization usually is benign. For example, it could be an in-house developed backup utility or a scripted maintenance task. However, you should be concerned about unknown TCP or unknown UDP that appears in sessions going to or coming in from the Internet. Before you block unknown TCP or unknown UDP, try to identify the traffic by using the traffic log and packet captures, and instead create a custom application or configure an application override policy. Updating App ID. Palo Alto Networks adds new applications to the App ID database nearly every week. You can schedule an automatic download or automatic download and installation of the updated App ID database. Updated content also can be manually downloaded and installed. The App ID database is downloaded as part of the Application and Threat Content Update. You can schedule App ID updates to be automatically downloaded and installed. However, sometimes the identification of a new application might interact adversely with your current policy rules. For example, an application that formerly was identified as web browsing and allowed by a policy rule might be blocked after an App ID update because it becomes a uniquely identified application with no matching security policy rule. However, you can pre-analyze the effect of new application signatures on your policy rules before enabling the new application signatures in App ID. This pre-analysis capability is included in PAN-OS 7.0 and later. To enable the capability to pre-analyze the effects of new application signatures on your policy rules, check the Disable New Apps in Content Update checkbox. New App ID content updates will be downloaded and installed, but any new application signatures will be disabled until you individually enable them. Note, the capability to initially disable new App ID signatures applies only to content updates with a version prefix of 484 and later. Starting with PAN-OS 8.0, you can schedule a firewall to check for new updates as frequently as every 30 minutes, in addition to being able to check just daily or weekly. Palo Alto Networks still makes applications and threats updates available just once a week, but your firewall can now check for updates more frequently, which can be useful because urgent updates can be released at any time. To pre-analyze the interaction of new application signatures with your current policy rules, click Review Policies. To enable new application signatures in App ID, check the Applications checkbox and click Enable. Only application signatures released in new content updates with version prefix 484 and later can be disabled. The Policy Review window enables you to investigate and view which policy rules will match new application signatures.